Hello and welcome back to CST 2120. In this lecture I'm going to cover Node.js and MySQL. So in the lecture on Node and Express I showed you how to sort of create a basic create the interactions between the client and the server with the data all being stored sort of in an array in that case. So in this lecture I'm going to show you how you can store and retrieve data from a database using Node.js. And then obviously for your projects you've got to put together the storage and retrieval of data that I'm covering here with the exchange of data between client and server that I covered in the lecture on Node and Express. Okay, so Node.js and databases. So in coursework 3, I've stipulated you have to use an SQL database. So things like NoSQL databases like MongoDB are sort of not allowed. You have to use an SQL database. And there's a lot of SQL databases out there. We've got MySQL, which I'm going to cover in this lecture. There's PostgreSQL, I think it's called. There's Oracle and various other ones as well. Yeah. So I'm going to show you how to use Node.js with MySQL, but because SQL is actually a query language, as I'll explain a little bit, and you probably know already, that query language SQL works with a number of sort of related databases. So if you want to use a different SQL database, you can just take what I've shown you here and then just apply it, in a slightly different way. You probably just have to connect in a different way. Most of the other commands will be the same. So you are welcome to use a different SQL database, but in this lecture I'm going to show you how you can use MySQL because it's free, fairly easy to use, and it already comes with XAMPP. So, okay, so let's start with giving an overview of MySQL. Then I'm going to talk about how the database and the data inside it is actually structured into databases and tables. And I'm going to give you a sort of introduction. I know you've done a bit of SQL already, some of you. But you can regard that as a refresher or skip through these bits if you know it already. But for those of you who are a bit less familiar with SQL, I'm going to run through some sort of typical examples, things like select, delete, update, and also join. So once I've explained how SQL works in a very introductory way, then I'll go on to show how you can actually use Node.js to run SQL commands and store and retrieve data to and from a database. Okay, so MySQL is a popular and free database management system. So all these it's a piece of software, right? So MySQL is a piece of software, Oracle is a piece of software, and that manages an actual database, which is some kind of data structure on a file system of a computer, right? So whereas MongoDB is not ACID compliant, MySQL and a lot of the sort of related older databases are typically ACID compliant. That means they're sort of atomic, so either the transaction happens or it doesn't. They're consistent, so one transaction brings the data, from one valid state to another. So they've got these kind of different tables of relationships between them, so make sure that all those relationships are consistent. They're isolated, so it doesn't matter whether you're running in serial or parallel. And the durability means that the transactions and all the changes to the data aren't just in memory. If the database system crashes after the transaction, that won't affect the transaction itself. It'll still be stored in the file system. Obviously, durability doesn't extend to smashing up the hard drive or something like that. Yeah. So MySQL is pretty good. It's been around for a while now, so it's high performance database. It's free. Widely used, it's a classic LAMP stack, right? Linux, Apache, MySQL, and PHP. So the sort of PHP MySQL is a sort of classic combination, but you can use MySQL with lots of other sort of programming languages as well. Yeah, it's fairly easy to use. I mean, there's lots of the good thing about it is not only is MySQL so easy, free and easy to get up and running on your computer, but you can also there's also sort of various tools that will easily talk to MySQL. So MySQL is based on what's called a structured query language, or SQL. I'm going to go into some of the sort of details of that in the next section. And as I said, there's lots of supporting tools, so I'm using HeidiSQL in this lecture. So there was some kind of weird split. So MySQL used to be this sort of open source database, I think. And then for various reasons, maybe it's taken over, I think it's taken over by Oracle, maybe. But anyway, there was a fork, basically. There were the people who wanted to keep MySQL, true to its original vision kind of thing. And so for various reasons, MySQL went in a direction people didn't like. So they created MariaDB as a kind of fork of MySQL. It's still compatible with MySQL. All the same SQL commands will run on it, but it's just a different code base. It's a code base that's similar to the MySQL code base, but sort of evolving in a slightly different way. So with XAMPP, you don't actually get MySQL, you get MariaDB, which, as I said, is this fork of MySQL. I can't remember, 2009. So it's got 11 years of independent development on it, I suppose. So MySQL, I'm going to call it MySQL, but it could equally be called MariaDB here. It's a piece of software essentially, yeah, called a relational database management system. And when that software runs, it manages files on the computer. It has its own kind of file structure. You don't see the files ever, unless you really want to, but it manages these files on the computer containing the database. And then this software listens on a particular port. So MySQL runs on 3306 by default in XAMPP. I think probably by default in general, so it listens to commands, and then other programs connect, they make a socket connection on that port to the database, and then they send commands to the database to do things like insert, select, delete, and so on and so forth, and then they get back a response either containing data or confirmation that the command's been executed. So it's really it's a piece of software listing on a port, communicating with other bits of software, and the communication's all about doing things to the database, in the case of MySQL, by using the structured query language, or SQL. So to run it, if you're running on your own, working on your own computers, your own laptops, you can just download it, install it for free. I've got a hunch that the version you download has some kind of complicated root password already set, so you might need to be careful about that. So just read the instructions carefully. I'm not going to go into that here. But in the case of most of you people running on either lab machines, or if you just want the simple solution, you can just download XAMPP, because there's a version of MySQL already packaged with XAMPP, and it's very easy to start. So if you've got XAMPP already installed, you've already got MySQL installed, so you don't need to do anything else. All you do is click on the button to start MySQL, and that should just get it running. Yeah. So if you look at XAMPP, so previously we were using Apache, right, in XAMPP, but now here's MySQL is also there. So all we have to do, and this is a portable version, or should be. I'm pretty confident it's portable. If it's not portable, let me know, but I'm fairly confident it's portable. The version I've given you on the course website. So you just click on Start. The Start will change to Stop, and you'll see the port that MySQL is running on. There's also a configuration file you can launch there if you want to change the port it listens on, something like that, yeah? And then you should see status detected running. So almost certainly it'll be the same as Apache, that it won't run unless the XAMPP folder is at the root of a drive. So just make sure that's the case. Don't sort of leave it in the portable XAMPP folder. Unzip it. So XAMPP, that folder called XAMPP, is actually at the root of your drive. It can be a C drive or a USB stick or whatever, yeah? Okay, so that's pretty straightforward. So that's the easiest way to get MySQL running for your project, since you already have XAMPP running, I'm guessing, on most of your computers for your other pieces of coursework. So once you've got MySQL running, the sensible thing to do is to change the password on the root account, because the version that comes with XAMPP doesn't have a password. There's just to get into the database, you just type root and no password, and you get straight in. Yeah, so that's a sort of massive security vulnerability, and if it was a commercial system, you'd obviously need to fix that. Yeah. So the sort of correct thing to do is, well, change the root password, for example, but also then create a separate account that has permission to create databases, change the data, etc. And obviously, if you were doing a real system, you'd have a sort of limited account provided for Node that maybe doesn't give it permission to change, delete tables or something like that, but just has permission to select data, whatever minimum set of privileges are required to actually run your website. That's what you typically give. You create an account for that and use that account within Node and other software that had to interact with the database. So you can do all of this stuff with the database by typing SQL commands into the MySQL client. So that's entirely possible, but generally people prefer to use a graphical tool to interact with MySQL. It'll do some of the sort of error checking. It'll display all the results easily and prettily. There's quite a few graphical tools for MySQL. A lot of you use sort of PHP admin, MyAdmin or something. But personally, I prefer HeidiSQL. It's a nice, portable, simple tool. If you have problems with it, and I have had problems with it in the past, then just download the latest version, latest portable version. So I had some problem with configuring root accounts with the old version I had on my computer, but I downloaded the latest version, they'd fix the problem. So it's, it's a nice tool, but you might want to use the latest version if you're having difficulties with it. So HeidiSQL, it's a graphical tool, lets you manage MySQL databases. So this this is just a tool. People often confuse things like MySQL or PHP admin for the database, but it's not. Yeah, Heidi is a graphical tool, a software package that talks on a port to the MySQL software, the relational database management system, and that relational database management system interacts with files on the computer containing the actual database. So HeidiSQL is not a database, it's a graphical tool for interacting with the relational database management system. Okay, just be clear about that, because I've seen lots of people saying, oh, you know, I'm starting MySQL, PHP in my admin, is that my database? And it's like, no, it isn't. It's the database is technically probably the file, the structures on the file system that are managed by the relational database management system. So anyway, Heidi is easy to use. You create tables on SQL commands and so forth. As I said, I put a portable version. I'll make sure that the portable version is the latest version, so you have less issues with needing to download the new version. But you can also download and install it from HeidiSQL.com. So it is, quick look. We're going to be using it quite a bit in this lecture. So first thing we want to do with HeidiSQL is create a user account. We're going to use this user account for our, in order to for the software for Node.js to be able to do things with the database. We could also use this user account to log into the database itself. But, you know, I mean, it's only it's a sort of student project, right? So we're not going to get too worried about security, but I think it's worth, at least in the minimal, learning how to create a user account and using that for your code, okay? So it's pretty easy. So first thing you have to do, obviously, is start MySQL or MariaDB, whatever you call it, because without that, you're not going to be able to talk to the database at all, yeah? So first we start MySQL, just like you used to have to start the MongoDB server in the previous bit of coursework. Then we can launch HeidiSQL, and then we can connect between HeidiSQL and MySQL or MariaDB by providing the appropriate authentication details, yeah? So when you start, you get this kind of session manager thing. And then you sort of, once you've logged in with the root account, with root and no password, so here, I think I've got root, no password. So when you initially start up MariaDB/MySQL, we can connect to it with root and no password, as long as it's running on 3306. We click open, that will connect to the database. And then inside Heidi, we can then add users using the user manager here. And we click on add, we type in the username and password. I recommend to give the user that you create appropriate privileges, and it's generally easier just to give it global privileges, but if you were doing this properly, you'd restrict the privileges, so I explained, and then we just click save and we got the new user, yeah? So here's the user manager, so we just give the user a name, we say where the user is going to connect from, give it a password, and then we select the privileges appropriately and save it. And if you want to connect with that user, then you can restart HeidiSQL and enter the new details, and you'll then have the user account with full privileges. Probably won't bother with that stage in the demo, but we can also use the same method to add a secure password to the root account, which should also be obviously very sensible. All right, so let's give it a go, yeah? So if we go here, this is my XAMPP. So I've already started this here. I've clicked on start. You can see it's running on port 3306, and it's telling me status, you know, running and all that kind of stuff. So that's sort of dead easy. And then we come to then I've just launched HeidiSQL here, and so all of this is the same. So I'm just using the root account here without a password. If I click on open, here we go. So here's now I can see all the databases that are running on my current relational database management system. I think it's tools, user manager, right? So I've already created some users here already, but I'll just show you how you can add one. We just click on add, and we add user demo, let's say, from host. And password, you know, 1234, it's classic, right? 234. And then we select the privileges. So we could select sort of global privileges, all that stuff. So that's kind of giving it permission to do anything it wants, same as root, which obviously is not what we do if we're doing a real system. If we had a real system that we're running code on, we might want to, for example, we don't want to create table space, whatever that is, create users, we wouldn't want to do. There's a bunch of stuff we wouldn't actually want to include, but you know, for simplicity, we'll just save that user, yeah? So now, demo is one of the users in this list, and I could use demo1234 instead of root and no password to connect to the database. Okay, yeah, so close that, check this thing's running, yep. Okay. But, you know, it's not essential for your coursework that you create a separate user account, but I recommend you do it just to get a feel for it, okay? Right, so once we've authenticated ourselves with the database, the next step is to actually start creating once we've authenticated ourselves with a relational database management system, then the next step is to create some databases and put some tables in them and start playing around with the data, yeah? So in the previous piece of coursework, we were using MongoDB, and that has one or more databases. Each database has one or more collections, and each collection holds one or more documents, yeah? And the data is stored as fields in the documents, in these kind of JSON documents, yeah? So on the other hand, MySQL, again, it has one or more databases. Each database, in this case, holds tables, and each table has one or more rows in it and one or more columns, yeah? And then the data is in as rows in the table. So it's a much more defined structure. MongoDB, you can add a document with any old structure to any old collection, whereas with MySQL, you have to, some of the rows have to, you can constrain it so that the rows can't be empty. They actually have to have the data that you've provided, yeah, that's specified by the table. So with, if you remember with MongoDB, we had what's called a primary key, which is this kind of unique identifier, the object ID, and each document has this unique identifier which is generated by MongoDB. And so this is what's called a kind of a primary key, which is an identifier that's unique to each kind of chunk of data. So with MySQL, within each table, you have what's called a primary key. So each row has to have something unique about it that separates it out from the other rows. So with MongoDB, the object ID is kind of unique to the entire database. Whereas with MySQL, the primary key is only has to be unique within an individual table. So when you're creating your tables for your database, you can either use something that's going to be unique that you know is unique. For example, if you're having a users table, you might have, the email address might be unique for each user, and you might enforce that. Or it could be a combination of things. So you might have two things about a user that taken together are unique. I'm trying to think of a particularly good example. Probably isn't, I can't think of a particularly good example for users, but in other contexts, you often have two things that taken together uniquely define a particular row in the table. Or the easiest thing to do, which is the thing most people do most of the time, is that you kind of create your own primary key, just an integer that's sort of that's unique for each row in the table, and you can actually configure MySQL to automatically increase this integer when new data is added to the table. So here we've got some tables. I forgot, yeah. So here's the columns, right? Name, address, telephone, email, sort of classic kind of user table. And then if you look at the end here, we've got this ID field here. And I've configured, this is the sort of HeidiSQL view of this table, showing the different field columns, the data types in those columns, and you've got things like length, and you've got whether you allow null entries or not. And here I've actually set ID up as the primary key, and I've set it up to auto increment. So if I just insert a new row into this table without specifying the primary key, it'll add it, in this case, with an ID of 14, for example, yeah? Now you can have obviously quite complicated tables, in this case showing kind of, relationship between the tables. You have this kind of foreign key relationship, which I'm going to come to in a little bit. And then when you're designing your database, there's a whole set of rules for designing databases called sort of normal form. You have sort of first normal form, second normal form, third normal form, Boyce Codd normal form, I think even fourth and fifth normal forms. And these rules constrain how you design your database so you can avoid lots of duplicate data in different tables. Because if you've got duplicate data in different tables, most likely you're going to have a real struggle to kind of update that data when you need to change it, because you might have to change it in lots of different places and it gets very confusing. So you ideally want to design a database that's nice and clean, very tight, so that you don't have lots of duplicate data in it. So I'm not covering that in this piece of coursework, but I can give you some guidance on that in the labs and in the Q&A session, and that's something I cover in my module next year, where I actually go properly into the different normal forms and give you feedback about that, and there's some marks available for that if you do my module next year. So we created our tables in this case, a database in our tables, let's say, and then we want to be able to change things within the tables, and we do that using this structured query language, or SQL. So with MongoDB, we had some methods, right? We had things like find, delete one, insert, and so on, that we used with sort of appropriately formatted JSON formatted sort of parameters in order to be able to manipulate data in our table, yeah? In our collection in that case, yeah? But with SQL databases, we have this special language called SQL, which can get pretty complicated, and we use that language to interact with the database. So we could use SQL to create the databases and tables. You can use SQL to do anything at all within a database. But generally, when you're doing basic stuff like setting up your database, it's easier to use a graphical tool, and that's why I've been introducing you to using HeidiSQL, because that's quite a nice graphical tool for doing this. Yeah. So if we want to create a database, we can just right-click on the name of our connection called unnamed. We select Create New Database, give it a name, and then we create a new database. So the database is sort of wrapper for all of the data in a particular kind of for your project, for example. Yeah, you have one database for your project. You don't create databases when you should be creating tables. You should have one database that holds all of the tables, that will hold all of your data that's appropriate for your project. Once we've got a database, we can then select create new table. We can add the columns, select appropriate data types, add a primary key. That's what you usually do. Save the table, and then you've kind of got the thing all set up. Yeah, so you should be. I'll go through this in a little bit of detail now. Yeah. So let's do a little demo. Yeah. So I'm gonna show you how to create this stuff, but I might use my pre-existing ones when we come to the actual testing stuff. Yeah. So here we've got the connection here, or the connection, and then we do create new database. Okay, so let's all call this demo will do, right? And then we've got a demo in there, yeah. So there we go. Clicked create a database. Now we've got demo, this kind of empty database here, yeah. Then inside the sort of space of demo, we can do right-click, create new table. I'm going to call this table. Let's do the classic. So employees, for example, and then so we're going to give the table a name. I'm going to add some columns, yeah. So we could do let's start with the primary key. So we're going to call it ID. The type, so databases that are typed, SQL databases are typed, so each column can have a particular type, yeah? So in this case, I could give it an int, float, char, and there's lots of various rules constraining how much data you can store with each of these different types. But for the moment, we're going to use int is a very sensible type for an ID. And then we'll do create new index. It's primary key. Okay, so you need to right click, create new index, primary key. And then I think we can default, if we click on default here, we can select auto increment, yeah? So remember, right click, create new index, primary key, and then I set the default to auto increment. So when I add new data now to this, whatever it's called, employees table, then it will automatically generate the ID for me if I don't specify it. Okay, and then let's just create some simple stuff. Name. Now name, we've got lots of possibilities for the name type. Char will give us up to 255 characters, so that'll probably do, yeah? And then we can add another one. What do it? Maybe char. Is that sensible even? Okay, ranges M. Yeah, that's right. Yeah. Okay, then name. We're going to call this, let's say, email. Yeah, let's save myself some typing. Name, email. Maybe we'll leave that as varchar. So varchar means it's a more variable length string. There's lots of optimization stuff you can do here, although these days a lot of these optimizations were designed when data storage was expensive, but these days data storage is not expensive, and that's why you don't necessarily need to bother with worrying about whether you're storing it as a char or varchar, because the data storage you're paying much more probably to access the database than to actually store the data, particularly when you're using the cloud. Okay, and let's do address. We'll leave that as varchar as well, yeah. So here we've got our table, primary key, name, email, address, and then we'll save our table. And then if we now look on here, we've got demo, and then we've got the employees table, and here's our employees table there, yeah? So pretty easy, yeah? Okay. So next step, once we've got our table, we want to actually start putting some data into it and retrieving data from that table, yeah? And we're going to use SQL to do that, this structured query language, and that has a certain sort of syntax for inserting data, selecting data, updating data, deleting data, and so on. It's complex. You can end up with some really sort of big, sort of chunky kind of queries. And I worked at Trinity Mirror, I had some real nasty Oracle queries to do complicated things. But the nice thing about it is these queries are typically optimized and fast, yeah? So if you can do something in SQL, you generally should try to do it in SQL rather than taking out the complexity and put it into your code. Yeah, if you can do one single call with SQL to select the data in exactly the format you want it, then you should do that rather than trying to, pull out one bit of data and then pull out another bit of data from a different table and then merging them together, because the SQL will be fast, optimized, you can index it, all the rest of it. So in general, always aim for a more complicated SQL query rather than lots of little queries that you stitch together with code. Yeah, but these complicated SQL queries are complicated. Yeah. So the most complicated I'm going to show you in this lecture is to do a join statement, but they can get way more complicated than that. So don't try and sort of become an SQL master in the next 3 weeks. Just pick up as much as you need to do, as much as you need for this project. Okay. I'm only going to give a very short introduction here. If you really want to get better at it, you need to play around with different commands and sort of and follow a few tutorials. So first sort of thing we might want to do is put some data into the database. So we've got sort of two versions of this command. We can do insert into the name of the table here. We can specify the columns and then the values here that go into these columns for a particular row. Or we can just insert into the table name, and then as long as the order of these values matches the order of the columns in the database table, then all these values will go in the correct place. So here I've got my employees, so I could do insert into employees, name, address, telephone, email. That would work, or I could specify the fields and then put them in a different order if I wanted to. So here we've got insert into employees, email. So here I put them in different order, right? So here I've got the order here is name, address, telephone, email, but if I specify the order, then this field here will go into email, this will go into telephone, this will go into name, and this will go into address. So it doesn't matter so much what you do as long as you do it correctly, yeah? So when we run that command, then we'll see the new employee appearing there. Okay, so let's do this with my my new table. So in Heidi, again, we could run all this on the command line, but with Heidi, it gives us the ability to so I'm actually going to comment that out because I might need that later. So SQL comments are just standard, this kind of stuff, yeah. Okay, so if we want to insert some data into employees, we can do insert into employees. And I need to make sure I want to run that on. Yeah, I'm in demo employees. I need to make sure I'm on the right database, right? And then values. I'll probably change that. Right. Okay. So let's do this in a simple way. So I've got name, email, and address. So name, David, whatever, and then it's d@g.com. And what was the third bit? Address, I think it was, wasn't it? Address, yeah. So 3 example walk. Okay, and then to run it in Heidi, we just click play. Wait a minute, column count doesn't match value count. Right one. Come on. Insert into employees. I maybe need to specify it. Name. What's my example? No, I don't think I know. I just want checking. I didn't need to do the quotations. No, I don't. Yeah. Okay. So let's go back to this. Employees. Oh yeah, that's it. Yeah. So employees. Yeah. Okay. So name. Email, address. I think it's case sensitive, so I don't want that to be auto completed. Okay. Right, great. So I ran the query, right? I specify here name, email, address. So if I put in a primary key here, I think I could have got away without. Let's do 40 or something else. Be quite extreme. Let's make that John. Because I wanted the primary key to be auto incremented, I think I have to. So if I run that, whatever the warning was, yeah. So if I specified, oh wait a minute, now so put it in as address, for heaven's sake. It's a primary key there, isn't it? I think I can specify a primary key. If I run it like this, yeah, there we go, yeah. So if I didn't specify, so I can only get away with not specifying the column names if I put all of the columns in, yeah, which includes, it appears, the primary key one, yeah. Otherwise, if I wanted to do it the other way, I'd have to, if I wanted to auto increment the primary keys, which is much better, then I need to specify the names, you know, here, yeah. But anyway, there we go. So we just insert employees, specify the column names or not, and then provide the values, and then I've got my sort of three employees as it happens now. Okay. So once we've got some data, we might want to select some of that data. So we can do select. So we can either select specific columns, or we can select all of the columns from a particular table. And we can also specify rules that control which data is returned, because we don't always want to get everything from the database. Yeah. So here, I've got the employees table. So if I want to select, for example, the name and the email from this employees table, I specify the fields that I want to return here. Then I specify, obviously, the table I want to run the query on. And then here I can look for specify rules, such as email equals specific email. And I can have like and or rules. There's various different kinds of rules you can use with SQL, like and or, probably XOR, this kind of stuff. And then if I run this query on here, I'm getting this employee. I don't know if it's giving, no, it's not. So I'm getting email equals d@g.com, wherever that's gone. So I'm selecting this employee because the email is d@g.com. And I'm getting this one here. Sorry, this one here, Carol@net here, this one here. It's an OR statement, so it's going to get both of these two rows, but it's not returning the whole row. It's only returning the name and the email fields from the selected rows. Yeah. So let's have a quick play with that in Heidi. So let's just see what we got here. Maybe let's just have a quick look. I've got some better ones here. Okay, so let's switch to my sort of slightly nicer example. So here I've got slightly more similar thing, right? Except, well, okay, actually not. Let's stick to this one, yeah? All right, this is a bit simpler to begin with, yeah? So here we've got name, email, address. So if we want to do the most simple select, we can just do select all from employees. Okay, so if we run that here, there's probably a shortcut, then we're getting all of the employees there, yeah? Now we can limit that. We could say where email equals, I think it needs d@g.com. So let's run that, yeah. So now we're getting, so there's actually two of them as it happens, two employees with the email equal d@g.com, yeah. And in this case, if I don't want to select everything, in this case I've got ID, name, email, and address. I could, for example, select ID and name from employees where that's my truth code here. So in this case, I'm only getting the ID field and the name field from this table where the email equals that. And there's various, as I said, and or. We can add extra rules, and you know, there's a lot of complexity we could add, but I'm not going to go into that here, okay? Because you're probably not going to need more than this, yeah? Right, so we've also got update. So if the user, for example, modifies their password or something, then we're going to have to use an update statement to sort that out. And it's pretty straightforward. We just do update, name of the table, and then we set the new values to whatever we want, and we can apply a where condition, which will select the table, the rows that are going to be updated. So again, it's a bit like MongoDB this, yeah? So here we've got our employees table. If we do update employees, set telephone equals where name equals Carol Smith, then name here is Carol Smith, and then it's going to set the telephone number to a new telephone number, so that instead of this telephone number here, we've got this telephone number here. So let's just do a little demo on update. So let's go back to my employees. Here's all my data. So let's change John's email, for example. So update, so the update command, right? Employees set email equal to, you know, j@b.net, where email equals, where name equals John. Yep. So let's try that. It'll probably give us some feedback here, like how many rows are affected, this kind of stuff, yeah. So let's just refresh it. So when we refresh it using this button in Heidi, we can see we've now set the email equals to j@b.net because it's because of our selection statement. Now if we get this wrong, yeah, we do EE or something like that, then it won't change anything, yeah. If we change it to set to email equals j.net 44 or something and run that query, it shouldn't do anything. Yeah, it hasn't changed that at all because it hasn't been able to find it, yeah. So I think that's most of what you need for update. Update's not terribly complicated, really. Probably, let's just test this, yeah. Let's get rid of the where. I suspect it'll update everything. Okay, so here we're getting an alert, right? It's saying run unsafe queries without a where clause. So if I don't supply a where clause, it's going to set all of the emails to j@b.net 44, which is probably not what we want. So I'll just say I don't know what I'm doing because I don't want to do that. You always need to supply a where clause when you're deleting or updating, otherwise you're just going to trash your database, yeah? Okay. So delete is the same sort of idea as update, except we're not setting anything, we're just trying to delete particular rows. So again, we're going to delete from a particular table and specify a condition that will pick out the rows that we want to delete. And that's this where condition here. And as I said, like with update, take care with this. If you omit the where condition, all the data will be deleted in the table, yeah? So, you know, use with caution, yeah? So if we do here, we're deleting from employees where email equals Wendy at whatever, it's going to pick out this specific row and delete that row, but leave all the rest untouched, yeah? So again, let's, and in case I forget to say it later, okay, sorry for the interruption. So what I was trying to say is that if you're going to be writing SQL in your in code, yeah, and running that code in the database, so often you'll find that the query is wrong for some reason, and so the best thing to do in that case, if you're getting some kind of weird error, you're not understanding why it's not doing what you're expecting it to do, is take the SQL out of your code to make a copy of it or output it to the console, and then put it into Heidi or a similar tool, and then just run it manually on database and make sure your database query is correct. And when your database query is correct, you can then go back and look and put the SQL back inside your code, and then try and figure, you know, and hopefully that'll fix the problem, or the problem probably lies elsewhere if the SQL is running just fine. Okay, so we're doing delete, right? So let's do a quick delete. Okay, so let's just let's pick out something. So by ID is pretty safe, yeah. So again, if we do delete from employees, where ID equals, I think, 45, wasn't it? Yeah. So again, we execute that. Get our table, refresh the table, and we can see that the employee with ID 45 has been deleted. And again, if you forget the where and you're running a real system and you haven't got safety checks in place, then you're going to get in real trouble, yeah? Because if we try and run that, it's double checking here in Heidi. But if I run that here, it'll just delete everything in employees, which is usually what you don't want, yeah? Okay, so next thing I want to cover are foreign keys. So if you want to produce an efficient, compact database structure that doesn't have lots of duplicate data and is easy to maintain and so on and so forth, then we usually put different types of data in different tables. We might have one table for employees, one table for companies, you know, one table for kind of jobs. You know, a typical database, SQL database for a big company will have, you know, lots and lots of different tables holding lots of information, different information. That's why database design is quite a complicated business, and they've developed all these different rules that will help you to do it well. But we're not going to go into that in massive detail in this piece of coursework, but I will introduce the idea of foreign keys so that you can have that enable. If you have with foreign keys, you can put different types of data into different tables and then link those different pieces of data together in systematic ways, yeah? So typically as a foreign key, you include the primary key of one table as a column in another table. That's really what a foreign key is, yeah? So if we go to, so I've added, stuff I created earlier, right? I've got a sort of more sophisticated version of my employees table here. So it's the same as it's address, telephone, email, name, that kind of stuff. We've got the same IDs here. But here we have a foreign key, okay? So the employees contain so we also have a companies table here with just a name, very simple table, just for simplicity, just to illustrate. Inside the companies table, each company has an ID, and then this company ID is a foreign key inside the employees table. So the employees have an ID here saying which company they work for. Yeah, so in this case, John Smith works for Google, whereas Jane, Emma, and Pete, they all work for Microsoft because they've got this ID here. Yeah. So yeah, John Smith works for Google, and these guys work for Microsoft. Yeah. So within Heidi, we can create data with these kind of foreign key relationships, and so different tables linked with this foreign key thing. I don't know if I've got a. Let's just before I go to that, before I go to inner join, let's just show you how to create a foreign key relationship in Heidi. So here we've got my employees. Let's create a new table. Can I create a new table? Yep. We'll call this. Let's just create an example. Companies. Say. And we'll keep it simple, yeah, we'll just have an ID, integer. So again, remember, right click, create new index, primary, add a auto increment column. Yeah, might as well. Okay, and then we have Google, name. In this case, it's a string, we'll just use it for char, yeah. And then that's all we need for our company, right? So we'll save, save that. Now to do the foreign key, so to create the foreign key relationship, we then need to, we might end up in trouble here, but let's give it a go because we've got data in the database, and then that gets a little bit sticky, but let's see if we can make it work. Yeah, so then we can add a company. If we get problems, I'll just delete the data. Yeah, so we've got company ID here, and then this is a, where's my integers? Integer. Okay, so here we've got company ID, so we're going to save that. Yeah, and then here in Heidi we have foreign keys. We can add a foreign key, and then we can sort of okay, so usually we can, why can't we? Okay, yeah, so we click on here on columns. So in this case, well, let's do, so the column in this case is company ID. Okay, that's the column here that holds the foreign key relationship. The reference table here is companies, and this is foreign column is the field in the foreign table. In the other table, the companies table that has the ID here. So this is employees table, the ID in the employees table. This is the place that's referring to. It's referring to company ID, refers to ID inside the companies table. Okay. Now we'll try and save that. Yep, thought we'd have a problem there. So let me just show you this delete statement. So if we do delete from employees, we run it anyway, and that's deleted all the employees. Now probably we're going to be able to create a foreign key now. Yeah, there we go. Yeah, so it wouldn't let us create one because it would create an inconsistency in the database, because there'd be some rows that didn't have that foreign key relationship. But since I haven't got any rows, now I've got no data in the database, I can then put in some now I've created the foreign key, I can then put in data that has the appropriate foreign key relationships. Yeah, so the database is always trying to protect, this is ACID business, right? It's always trying to protect us against inconsistency in the data. Okay, so now we've got a foreign key in our database. I'll show you how to do it at any rate. So foreign keys are good. They let us create different tables and express the relationship between the data in these different tables. But when we're doing select, then we got a problem, yeah, because we maybe want to bring together the data from the different tables without having to do lots of different calls to the database. Yeah, as I said before, when you're working with SQL, it's better to have a single SQL statement that brings all the data together that you need, rather than doing multiple calls to the database in code, because that can be a little bit tricky as well, as I'll also explain when we come to the code. So to handle that problem, what we have is a join statement that enables us to link together the data in different tables, typically using the foreign key relationships. Yeah, so there's lots of different types of join. I told you SQL was complicated, but we're going to focus here on inner join. Yeah, so here we want to select columns, potentially from two tables, possibly from more tables, and then we specify the relationship between we specify rules that control the matching relationship between the rows in the different tables, and then it returns the data we've selected from those two different tables linked together as this join statement. It sounds complicated, but it's actually not that complicated when we actually look through a particular example. Yeah. So as I said, I've created a sort of here's my employees table with the foreign key. This is sort of previous example. So here we have the company ID. Yeah. So here we've got Google and Microsoft, the foreign key thing I explained, a couple of slides back. And to run an inner join on this, it's really not that difficult, and you might need to just have a little bit of practice, but I'll just try and explain it as best I can here, yeah? So again, when we're running queries across multiple tables, we may have the same column name in those two tables. So in this case, employees has a column called name, and companies has a column called name. So we can't just do select name because we're running across different tables. So we have to specify which table we want the field from. So in this case, I want employee's name, in this case, this column here, and I also want company's name. So this is specifying which data gets returned, which of the columns gets returned from the query, yeah? I just want the employee's name and the company's name because I want to know the name of the person and the company they work for. Now, then I'm running this select statement on the employees. I could run it on the company's table, but in this case, I've just arbitrarily chosen to run it on the employees table. So I'm selecting from the employees, but I'm also joining the employees table on an inner join with the companies. So I'm selecting from employees, I'm joining with the companies. And the inner join has rules. Yeah, the inner join is on, and this is the rule that's used for the join. So I'm looking for when an employee's company ID equals the company ID, then it'll return that specific row. Yeah, so it'll do a select on this table, right? It'll find all of the employees here, and I could also have some other rules added on top of this, but I'm not going to bother with that here. So here it's going to return, wherever there's a match here, it's going to return the employee's name and the company's name, yeah? And so in this case, I'm getting all of this stuff, yeah? So let's have a little look at inner join. I might play around with a couple of things that are a bit fast and loose, but let's give it a go, yeah? All right, semi-typing. So let's go back. Remember I saved this rule earlier. So let's go to my database here, right? So I'm running the rule on this database here. This is the active database. So here, as I showed you, so here we've got the data. This is the employee. This is the companies with the, Google and Microsoft, and we've got the employees here, each of which has a company ID. So here I'm selecting these two fields. So let's just add another one here just so you can see what we're doing here. So let's also select the email, yeah? So suppose I also want the employee's email, yeah? Yeah, so these are the fields that I want returned, yeah? So I'm selecting from employees, and I'm linking that data with the companies, where the employee's company ID equals the company's ID itself, yeah? So if we run that, here we're getting the name of this is the name of the employee, the name of the company, and the email of the employee. And I think this is the fast and loose stuff, where employees, let's find all the names of the people who work for Google, yeah? For example, companies. Let's try that. I'm not certain it's going to work. Yeah, there we go, yeah? And so there we go, Microsoft, yeah? So you can see here, so here we're selecting the name of the person, the name of the company, a bit pointlessly here, and the email of the person for all the companies that work for Microsoft, or perhaps more useful if we wanted the name, the email address, and the company of a particular employee. So let's get rid of email. So we know the email of the person, let's say, and then we do employees.email equals hh@g.eu. Okay, let's just check that works. Yeah, so in this case, I've got a person's email address, and I want to know their name and the company they work for. Okay, so this enables me to do that kind of query. So there's lots and lots of increasing levels of sophistication, but this is good enough, I think. We've got two tables here with employees and companies, linked with a foreign key, and using the inner join, I can pick out, the right sorts of data in a single query that across those two tables, yeah? Okay, so the last, the sort of last 70 slides, or something like that, has been revision for some of you. but also maybe some of you skipped it, and some of you, this is maybe new and you need to look through this in more detail. But hopefully by this stage, you should be comfortable with creating databases using Heidi, creating tables using Heidi with various different kinds of columns with primary keys and so on, creating tables, multiple tables with foreign key relationships, and running queries across these tables to extract different bits of data and to add different bits of data to the tables. If you can do all that, you've got plenty enough, I think, and you're able to be able to do coursework 3. So this is all very well. This is the SQL part of the coursework, if you like, yeah? But the next stage then is how can we actually run those SQL queries, not using Heidi, but using Node.js, and that's what I'm going to cover now. So the first thing we need to do if we want to work with MySQL using Node.js is we need to install the MySQL module. So we change usual stuff, we change the root of the application, type npm install MySQL, and that'll install the MySQL module to your project. Now there's 2 ways that we can connect to the database. So the sort of, in some tutorials you'll see they do this kind of what's called what I'm calling a simple database connection, where you kind of open a connection to the database, do some stuff, and then you kind of close the connection when you've finished, yeah? So this is the kind of syntax here. We're using the MySQL module here. We use MySQL to create a connection with this, when we specify here the host, the user, the password, and the database we want to interact with here. And then we call con.connect, that'll connect to the database, tell us if it's worked or not. And then we do some stuff with that connection, like do some queries. And at the end of the day, we need to close that and release the connection so other sort of threads or other programs can use it. Yeah. Simple connections aren't great. So if you are looking at a Node.js MySQL tutorial, then simple connections it's not really the way to go. Yeah, because you can only use these connections within single threads. They can't be shared between threads. And if you're building a real web server, they're getting hundreds or maybe thousands of requests every second. And so you need to somehow provide multiple parallel connections. Opening and closing connections is slow and costly because you've got all this sort of socket opening and closing, this kind of stuff. And databases have a finite number of connections anyway. So simple connections really aren't the way to go if you want to build sort of robust, scalable applications with Node.js, yeah? The more sensible way to go is to work with a connection pool, which is actually a little bit simpler to use as well, yeah? So what we do is create a pool of connections, and then when you want to do a query on the database, then you run the query using the pool, and that will then extract a connection from the pool, run the query, and then return the connection back to the pool. So it's much simpler in a way. You don't have to mess around with managing your connections. All you have to do is set the size of the connection pool to match the capabilities of the relational database management system. So when you launch MySQL, you can configure how many simultaneous connections it can sustain, and then maybe you'll think about, well, okay, you set your connection pool to match that, or maybe less than that, or something like that. Yeah, so connection pools are a good way to increase the performance and scalability of your application. Connection pools are a bit less code as well. All you do, slightly old code, but anyway, it should be let, right, or constant in this case, require MySQL, and then you just do mysql.createPool. And here you can specify the limit on the number of connections, yeah? But, okay, so using connection pools, I'll go into a little bit more detail, what I can show you now, actually, come think of it. So let's start with my connection pool here, MySQL connect, yeah? So I'm not going to use the old syntax anywhere here. So the standard sort of using the connection pool, this could actually be a constant here. So we import the module, the MySQL module. So I've installed it here. If you look in my Node modules, I've got MySQL here, yeah. And then we do let connection pool, whatever you want to call it, do MySQL create pool. And then we can specify, so the connection limit. We've got the host, the user, that's incorrect user as it happens, password, database, and debug, yeah? So these should all match what you've set up in HeidiSQL when you created a user. So I've created a user called DG, as a password 123456. You could also use root and no password if you're working with your root account. And obviously the name of the database has to match the name of your database, yeah? So just to show you this working, so if I do node, what's this thing called? MySQL connect. So it does absolutely nothing because all it's doing is connecting and then finishing the connection kind of thing. But then if we put the details as wrong and run MySQL connect, then it's still doing absolutely nothing. What's that? Okay. I'm pretty confident in it. Let's just create some horrible errors in the code. Because I'm not totally convinced. Yeah, there we go. Okay, so it's running the right code, yeah? But why is it not creating a connection error? It did when I practiced it earlier. DGD. Okay. Well, let's put debug true, for example. Okay. So this should throw an error. I'm just wondering why that's not creating an error. Probably because maybe I'm not doing anything with it. Yeah, let's just quickly run the code with select. Yeah. Oh, sorry. Node MySQL. Let's just run the select code. Right, so that's working, right? I think if I change this to the wrong... right, there we go. So I'm not sure why my SQL Connect code's not working, not breaking rather, but in this case, probably because I'm running an actual command on it. If I put the details wrong, then it stops working, yeah? So maybe if I don't run connection query on it and it just sort of sits there, then I don't get an error. But anyway, this is the correct way to connect to your database. So yeah, I failed to demo the unsuccessful connection, except when I'm actually running some code, but let's not worry about that now, yeah? Okay, so once we're connected to the database, we can then build our SQL queries and execute in the database. So all of the sort of queries that we were playing around with in Heidi, we can build those queries within our code and then run them on the database, yeah? So I'm just going to run through some very basic examples here. We're going to insert data, select data across multiple tables, update data, and delete data. As I've said repeatedly in this lecture, SQL is a complicated language, has lots of features. I'm not going to cover it all in detail. You have to spend some time learning SQL on your own. If you want specific things I haven't covered in here, we'll help you in the labs, or have a little look at some online tutorials or documentation. So in each of my examples, I start off with this piece of code that I've just showed you, where we use the MySQL module, and then we create a pool that connects to the database. And then the next bit of the example is the unique bit for each of these. So I'm not going to include this in each slide, right? But it's in the example code that I'll give you. Instead, I'm going to focus on this stuff here, the stuff that's unique. So in this case, the SQL. So as you can see, I'm inserting into the employees. These are the rows that I'm specifying here, and then I'm adding some values here, yeah? So, and then all I do to actually execute, so build the SQL, and the same should be true for any of this Node.js and MySQL. And then I call connection pool.query. So here I'm using a callback function. So I provide here the SQL that I've created here as one of the arguments. And then here I have a function, and that function will be executed when the query is successful. So it's what's called an asynchronous call. So it's a bit like an XML HTTP request. So it'll call the database, and then your code will just keep running or whatever. And when the call to the database is finished, it'll call this function here, either with an error as one of the arguments, in which case if something's gone wrong, or with the result of the query. Yeah. So when this function's called, which will be a bit later in time because it takes time to talk to the database, then it'll either be called with the error, in which case we're going to check and output the error. Or if it's successful, we can then log out the result here, yeah? Okay, so let's start with the MySQL inserts demo. So let's, where are we going? MySQL insert. Okay, so as I said, this stuff is kind of generic to all of my code. I'm going to focus here instead on the stuff here. So here I'm using the database, not the one I created in the demo, but one I created previously, this database here. My database, which has companies, and it has some employees, yeah? So it's pretty much the same, yeah? But, okay, so let's just run, so I'm just going to run this code. What this code is going to do is going to build this structure here. It's going to insert Wendy Adams. Let's call it Wendy Adams 2, just so it's clear what's going on. And Wendy Adams, here's the foreign key here for company ID. So that has to exist in the database or this isn't going to work. So we're going to specify Wendy Adams works for Google. So let's just do Node MySQL insert. Okay, so field count, affected rows, so we even got the ID of the inserted row here. And so then if we go back to employees, data, and refresh it, yeah, here we go, right? Wait a minute, no, why haven't we got, why hasn't Wendy turned up there? Probably because I saved it, yeah. Right, okay, let's call it Wendy Adams 3 or something, just be clear. So this time we're saving it, let's just run it again. Okay, and let's refresh it, and there we go, yeah. So I didn't save my file, yeah. So here we've got a new row going into database, and if you look at what comes back here, we've got the insert ID here. It's told us that one row has been affected. So this is just the feedback here about the insert operation. Usually this isn't necessarily very useful, but it might be helpful if you wanted the ID of the inserted row, for example. And there we've got the new piece of data. Okay, so with MySQL connection pool, your Node file, your Node application will keep running. It doesn't sort of terminate, so you just have to sort of exit with Control-C, yeah? Right, so let's go on to selecting data. So it'll run, it's the same principle. We just build the SQL query, execute it using the connection pool, and the result here is a JavaScript object that contains the array of the results, yeah? Each object in the array is a row from the database. And if we're building a web service, like I described in the lecture on Node and Express, then we can just return what comes back from the database in JSON format. And that's sort of a very easy thing to do, yeah? So suppose we've got a function here called getEmployees. If we call this function getEmployees, it builds the query, select from all from employees. Again, we're using connection pool to execute the query. We've got the callback function. And here at the end, we've got console log, which is outputting the results. And if you look at the results here we've got an array, and each entry in the array is a row from a table. So this is an object representing one row in the employees table. This is the next row, and so on and so forth. So if you want to return something from a web service, it's a very simple thing to do. We just select all the appropriate data from database, and then just return it in JSON format just by stringifying it like that. Yeah. So let's do MySQL select. So all that stuff's the same. We're just selecting all the employees. So let's just, that is saved, isn't it? So node, connect, delete, insert, select. Okay, and so here we've called select, and you can't see it very well. And here's an array. For example, here's the last Wendy Adams 3 that we inserted at the end of the array. Yeah. So each object in this array corresponds to a row in the database that's been returned from the select statement. Now, one thing I haven't covered in this course, because it's complicated, and I'm trying to get you familiar with the basics of JavaScript and PHP and database and that kind of stuff. So I haven't covered some of the more sort of advanced features of JavaScript in this course. And one of those things is promises. And promises are there to kind of handle the problem of asynchronous JavaScript. So as I explained, when we kind of do a select statement, we have a callback function, and that callback function is executed later. You know, it's not executed we can't call when we call getEmployees, it sets up that callback function, but then at a later point in time, the event will be triggered that the data has come back from database, and then it will call that callback function. That's what it means by asynchronous, yeah? So when the results returned, the callback function is executed, that callback function there. And then we can do the processing of it and output the result. Now, that's fine. So if we were doing like a sort of web service or something, we might have here, this might be our handler for a get event on a particular path, and it'll have a request and response. And so that's fine. As long as we can pass that request, the response object to here, then the response can then be used to send back the data that we've got in the database. So that's kind of fine. The problems occur when we want to do several calls to the database. Like I said, we want to try and avoid that. We want to put as much as we can into SQL, but we can't always do that. So in that case, we might need to make, say, 2 database calls to extract the data that we need, or maybe we even need to do some other kind of asynchronous thing after we've done the database call, and before we return the response back to the user. So So one way of doing that is to nest the other calls to the database inside the callback functions. Okay, so here we've got a callback function here, getting some stuff from the database. So we could, if we need to make a second call for the database, we could make another call to the database here, and at the end of that second call, we could then return the results. Yeah. This is kind of nested callback structure. It's sort of typical in kind of older versions of JavaScript. Yeah. A more modern way, which I'm not going to explain in massive detail, but I will mention it so that you understand, what roughly how that works, would be to use kind of promises. That's a way in which we can have more neat syntax for doing effectively the same thing. We can kind of wait for one thing to happen and then do something else that is ordered in time. So it means that we have one callback, one asynchronous function does some stuff. We wait for that to finish, and then we do something else. So when I first started doing this kind of Node SQL stuff, I sort of rather naively wrote some code that looked a bit like this, which does not work. Okay, so do not use this code. I'm not going to include an example code just in case people get confused, but this does not work. But you might think that it would work, and that's why I sort of started using it, and then it took me a while to figure out what had gone wrong. Yeah. So here we've got a function, getEmployees. Now, wouldn't it be nice if we could write just a nice JavaScript function that does the database stuff and then returns all of the employees, yeah, after running a database query? So you'd think that wouldn't be so tricky, but it doesn't work. Yeah. So the idea is we've got getEmployees, it queries the database, gets the result, and then at the end of the day, it kind of returns the result. So that here at the bottom we have letEmployees equals getEmployees, which in theory would be this result returned from the database. And then we log out the employees, and then having got the employees, we then do some other stuff to the database to maybe get some other properties from some other table or do some other more sophisticated queries and like that. Yeah. So you might think that would work, but it doesn't. And part of the reason it doesn't is obviously this is a function here. So we're kind of returning this from this function. We're not returning it from this function. But more problematically, this happens, the callback function happens, later in time. So what happens is the code will execute this bit of code, set up the callback function, then it'll execute that, and then most likely it'll then execute this. So this will happen after it's already reached this point, and this was the point we were actually hoping to use the return data. Yeah. So if you run that code, employees is undefined. It's not returned from this function at all, partly because this is within a separate function anyway, but also partly because it's asynchronous. So this doesn't return what we want it to return. So this is undefined. Then it tries to output that, but it doesn't do it. And then it reaches this point in the code when we're hoping to use the data return from here, but it can't do anything because that data doesn't exist. And then at a later point in time, we get the employees actually being retrieved from the database and output on the console. Yeah. So here I've got my incorrect example. Yeah. So don't use this at home. So same sort of stuff. So what I wanted to do was return something from here, store it in here, output it here, and then do something else with it here. But if I run that code, so we do node, what was it called, incorrect asynchronous. Yeah, so as I said, my employee is undefined, so it executes that, then it moves straight onto this, then it moves straight onto this, and then later point in time, we finally get the retrieved employees being output to the console and not returned and copied into this variable as we'd hoped. Yeah, so this code does not work. Okay, so we need to rethink this. Okay, so one way of rethinking this would be to put this code, the do something else stuff, inside here. So once we've got the results, we then do something else. We can make another asynchronous call, and that would be okay. But the neater way of doing this is using promises, and they were invented really to solve this problem. Yeah. So promises enable you to sequence asynchronous events. I'm not going to go into the massive details, so it's a complicated feature. So if you're really struggling with JavaScript, I recommend you don't get involved with promises. But I will give you a simple example now for those of you who want to try them. Just give them a go. Yeah. So here we've got a select statement that I've kind of rewritten. I want to do the same thing. I want to get the employees. And then I want to do something with the results that's returned from the select statement. Yeah, maybe another asynchronous call. So here I've got my asynchronous function, and what we can do is can wrap it in a promise. And a promise is what it kind of says, right? It's a promise to do something, but it doesn't actually do anything until you execute the promise. So here we've got a promise wrapping our connection pool query, and a promise has two functions called resolve and reject. Yeah. And when resolve is called, you can pass in the results. That's saying the promise executed okay. And if reject is called, then that means that something's gone wrong. So we can pass resolve and reject into our promise that we're creating here. And then when they get the error with the connection query, we call reject. And when the connection query kind of goes okay, then we resolve it with result. Either result or reject or resolve will finish the promise. Yeah. So instead of returning our attempting to return our sort of the results of the database query from this function, instead it's an async function. And an async function means that it returns a promise instead of returning any kind of data. Yeah. So in this case, I'm returning a promise to do a query on the database. And then there's one way in which you can sequence promises, which I don't like, because I'll show you a better way, but just for completeness here. And the advantage of this is I can run this outside of an async function. The second method I'll show you can only run inside an async function, but this method can run anywhere. So what we do here is we're calling get employees, and then we call then the get employees returns this promise, and then we do with promise then we'll execute the promise. And then inside there, we can have a callback function with passing in the results of the execution of the promise. And then here we can then output the result of the employees, and then we can do something else. Yeah. And then here at the end, we're kind of catching or handling the error. So we've got here with result of executing the promise. Then we could do inside this, then we could then put another execution of a promise that has its own then and its own catch. So it can get a bit messy. We can get all these promises and thens nested inside each other. So that's why I don't really like this way of doing it. A nicer way of doing it is using a wait. So we're still working with an async function, but in this case, we're wrapping, we're still building a promise here. This is all inside a single async function. So here we're building a promise, but here we're storing a reference to it. We're not actually returning it. We're storing it in a variable. So we're creating the same promise that we did before. And here we're using the keyword await. This will only work inside an async function. If you write await outside of an async function, nothing's going to happen. So we're calling await on the promise. And when we call await on the promise, it will execute the promise, but it won't move on to the next line until the promise has either been resolved or rejected. Yeah. So now we're waiting for the promise. And then employees is the result of executing the promise, in this case what's resolved. And now we can output the result of executing it and then do something else if we want. Yeah. So I'll show you this working now. So here we've got that's the then syntax, which that's the await, and then I've also select promises 2 is I'll change the names probably when I upload the code, but this is the then syntax. And then here we've got the await syntax. Yeah, let's just run the select promises 1 with the await. So node select MySQL promises 1. Okay, so here we're getting things in the correct order. Yeah, so it's outputting the results of executing the promise and doing database selection or whatever. That's what we're seeing here. And then it's calling do something else. So if we didn't have the promise stuff and we just called it with a callback function, execute it with the callback function, then we go straight onto here. This would be undefined, and then we go straight on to do something else. But here, this is now coming after this, and that's exactly what we wanted. Yeah. And as a general note, I suspect, let's just double check this, but if we create a new terminal, yeah, if we add a terminal and try and run some other stuff, node select select, for example, it's still working. I thought we might get an error because we're running multiple connections in parallel, but it doesn't matter. Yeah. Okay. So we're selecting promises using await. As I said, you can just use this code as a starting point, and we can help you with it in the labs. Promises can get a little complicated, but hopefully that's a useful solution, because students have had the problems of trying to make multiple calls, and this is really the easiest way to do that. Yeah. Okay, so other couple of things I just want to cover. So updating data is exactly the same as we're running in HeidiSQL. We just build the SQL statement, and this ID here might come from your query parameters, for example, and then we just execute it in exactly the same way. I'll just quickly run it now. So if we've got MySQL update, we want to set. Let's just find an ID that actually exists. ID equals 5. Oh yeah, we've got ID. So let's set Emma Digby's email address, for example. Well, that's a set email equals joe@joe.com. I think her name's Emma, but it doesn't really matter, yeah. So update employees, set joe@joe.com where ID equals 5. So here we've got Emma Digby, ID 5. And so if we save that and run it, MySQL update, okay, and who knows what the problem that is. Did it run? Nope. Okay, let's try it again. So why have we got to? This is something a bit strange here. Oh man. So first thing we should try, right, is run it on Heidi, and I'm pretty sure it's going to run okay on Heidi. Let's just start that, yeah. So it's not a SQL error, yeah. So if we refresh this, we can see Emma Digby's changing. I kind of rather suspect, let's just close that, let's delete that shell. Let's just add right, let's run it in PowerShell. Let's create a new shell, yeah. So let's run node, well actually joe.com is not much use now, right? Joe66 at joe66e at joe.com, let's try that, yeah. Node, MySQL, updates. Right, okay, so some weird sort of, I think maybe I'm using W script by mistake and it's causing problems with that, yeah. Okay, so now we've got joe66 at joe.com, so it's, yeah, it's worked perfectly fine, yeah. I think some weird thing with the shell there, yeah. Okay, so delete, pretty straightforward as well, right? We just delete, we execute the SQL. Let's not, waste lots of time doing this, yeah, because I think it's pretty obvious to you now how it works, yeah. So let's go back to here, not to here, to here. So let's go to MySQL delete, and let's pick something to delete. Let's get rid of number 9, for example. So here I want to delete from our employees where ID equals 9. Make sure you include the where, otherwise you're just going to delete everything, which is, not so wise. Okay, let me do node, MySQL delete. We've deleted one row there, and now if we refresh it, we've got rid of one row. Okay, so that's the basics, yeah. I've shown you how to use MySQL. I've shown you how to run MySQL commands on Node. And I've said a little bit about the problem of asynchronous JavaScript and how you can solve that with promises. Now, if you wanted to do this in a sort of more sophisticated, perhaps more enterprise-oriented way, you might not want to execute raw SQL using Node. Yeah, so in a lot of sort of bigger frameworks, or bigger applications, shall we say, you don't want to just run SQL commands using Node because it's a bit fast and loose, and you can do nasty things, as we saw with delete data, for example. So what's often a better approach is to use what's called an object relational mapping approach. So within Java, there's a very popular sort of framework called Hibernate that enables you to map databases onto objects like Java objects. And so in the Java code, all you do is change and interact with the Java objects, and then Hibernate does the job of converting those operations into MySQL that's actually run on the database. So that is a sort of, it provides a safety net, or sort of better. So in terms of writing Java code, that's better because you're dealing with Java objects, not with SQL. And it also provides a kind of safety mechanism that prevents you doing sort of silly mistakes to your database. So you can do the same thing within JavaScript. You can do this kind of object relational mapping thing. So within your JavaScript, you interact with JavaScript objects, and then the framework takes care of the problem of generating the SQL code to manipulate the database. So the couple of frameworks, there's maybe more by now, but I'm only mentioning this because if you want to do a more sort of sophisticated approach to this, then object relational mappings would be the way to go. If I was building a big application using Node.js and MySQL, I wouldn't just be writing raw SQL commands if we could possibly help it. I'd be looking for some kind of object relational mapping framework to do that for me. The example code for this lecture is all available online on the course website. I've also provided a variety of links to tutorials and other stuff on MySQL, Node.js, and so on and so forth. And I think we're done, yeah? So in this lecture, I've introduced MySQL and explained how you can use JavaScript running on Node.js to interact with MySQL. So hopefully that's enough to get you started on the coursework. So you can now do the client-server stuff with HTTP. You can send JSON formatted data to the client, to the server. You can receive JSON formatted data from the server. And now, instead of just having a dynamic sort of data structure running in the server, you can then, using the material I've given you in this lecture, you can now store data in the database and retrieve it from the database, and then that can sort of close the loop between the client, the server, and the database. Okay.